Recording in progress.
Let's go ahead and get started. Okay, so we're starting a new chapter. Chapter 5 covers the quadratic equations. So far we've been working with linear equations. The quadratic equations means we're working with polynomials. Y'all remember those from chapter 1-ish? All right. Linear and quadratic equations are used the most to model motion. Engineers use them quite a bit. So they are a way to predict how real life data is going to, or they provide real life data to predict how their designs are going to function. So we've pretty much covered linear equations, and now we're moving on into quadratic. All right, so does anybody remember? This is sort of a combination of order of operation. Actually, it's just order of operation. How we would simplify these. So 2 times 3y squared. We've got to simplify the exponent first. So what would 3y squared be?
3 or 9y.
Right. So this is 2 times 3y times 3y. So if you really have to break it down. But you or just know that you're distributing that exponent. Excuse me. So it is 2 times 9y squared. We don't know what y is, but we know it's y times y is y squared. All right, and then the last step, we can multiply our coefficients or the constant because we're multiplying. So we can combine these. So our final answer, 18y squared. All right, what about number 2? So number 2, we're using the product property of exponents. So you can think of it with the exponents as we're adding their exponents. So this is, you sort of like just, you're multiplying like terms. Don't write this down. I'm just going to show it to you. So this breaks down. You can just pull everything apart because all of this is multiplication, right? -3y x squared. We know that that is multiplication. That's -3 times y times x times x. So all you're doing is you've got -3. Oh, come on, don't start now. Times x times y times 2 times x times y. So we use our product property of exponents. So our exponents here are 1, and whenever you multiply, I'm gonna cut that 2 there. Whenever you multiply variables, then you just add their or the like variables, you can add their exponents together. So it's -3 times 2 times x to the power of 1 plus 1 times y. That's, well, I'll use the y, 2 plus 1, right? There's 3 of them. So you end up with -6 x squared y cubed. That is the long way around.
Yeah.
You don't have to do it that way, but it's just sort of a repeat of, that's why I said don't copy that, right? That's essentially what we're doing. Now, the way that we write it is we just combine the like terms, right? So we multiply the -3 and the 2. We multiply the x times the x, again, these guys, and then the y squared times y. So again, we're multiplying them. So your understood exponent here is 1. So that's x squared because it's 1 plus 1. And then y squared times y is y cubed. Now before, we always had to make sure that we had like terms because we were adding or subtracting them from each other. So you had to have like terms because you were taking things that were being multiplied together and adding or subtracting them from another set of things being multiplied together. So you couldn't just mesh them together. In this case, everything's getting multiplied, at least for this section. So multiplied, obviously, if it's in the form of a fraction, then you're just multiplying times the reciprocal. But then you can you just combine them all using the properties of exponents. All right, so what about for 3? We're distributing an x, right? So this is x times 2x and x times negative y. So what's x times 2x? 2x squared. Yes. Right? The coefficient of that x is 1. So this is 1 times 2 and x to the power of 1 plus 1. So it just becomes 2x squared. And what's x times negative y? Negative xy. There we go. Okay. Kind of somewhat mostly remember this. I can put the property of exponents back on my bulletin board if I need to. And the polynomials. Well, we'll get enough practice. I think they'll start to make a little more sense. All right, so let's get into the actual lesson here. When you multiply polynomials, essentially all you're doing is distributing. So an important thing to note here is that the distributive property is what is used to multiply a monomial and a polynomial. So let's go back to these. What is a monomial? One what? One term, right? So an example of a monomial as long as if there's a constant variables are being multiplied or divided by each other. So a monomial could be anything from, x plus 2 divided by y. It could be just 2x squared, right? That's one monomial. All right, so what about a polynomial? There's two types of polynomials that have their own names. So what's one that has 3 terms? So a polynomial, poly just means more than one. So what do we call polynomial? So there's 2 types of polynomials. There's the kind with 2 terms. What do we call those? Binomials. And 3 terms? Trinomial. All right, so in this case, all the terms are only separated by addition and subtraction. So you've got like 2x squared plus x plus 3. No, sorry, that's a trinomial. I got excited. 2x squared plus x. Trinomial would be like your 2x squared plus x plus 3. Right, you've got 3 separate terms. So those are the only ones we have names. There are an infinite number of polynomials. It just means they have more than one term. But these are the main ones that we work with. Okay, so just a quick review of the monomial versus polynomial. So in example 1, what is our monomial? Make 2x. So the 2x, this is why you can combine them to create one polynomial. So in this case, our monomial is the 2x. And then we have a trinomial here. This guy. This is our polynomial, which happens to be a trinomial. Okay, so when you multiply polynomials like monomials and polynomials together, you just use the distributive property. So all you do is think of 2x as one number. You're distributing that one number. We just don't know what x is, but x is always x. Like whatever it is, it's always going to be the same value. So you're distributing that to every term inside the parentheses that is separated by addition or subtraction. Make sure I got eyeballs. Everybody's so tired. Okay, so that means, let's see here. We take that 2x, right? We're distributing it to all 3 of the terms inside. So again, I'm going to use baby steps for this one. We have 2x times 5x squared plus 2x times 3x minus 2x times 7. You could also say plus 2x times -7. Either way, just make sure there's a negative in there, just one. Only one negative in there somewhere. I just like to keep it as the operator. And so now all we do is combine each of those. So what's 2x times 5x squared? 10x. So what do we do when we multiply exponents? We add them. So what's my, so you're just adding one more x to 2x to x squared. So it makes it x cubed, right? So the 2 times the 5 is 10. The x times the x squared, that becomes x cubed. All right, 2x times 3x plus 6x squared. And then the last one, -14x. 2 times 7, which is 14. All right. And you would simplify or combine like terms if you needed to, which in this case we don't. All right, so that's it. Everybody good so far? We know what's going on. Okay. All right, so let's move on to the next level. That's the basic combining a monomial with a binomial. Now, we still continue to use the distributive property, but this right here, this it's called the FOIL method, is extremely valuable to make sure you have. You use the distributive property to distribute each term in the first binomial with each term in the second binomial. So we call it FOIL because it's the first term. So in this case, like I have a plus b times c plus d. So the first terms are my a and c. So you combine your first terms and then plus the outer terms, which is the first one in your first parentheses and the last one, so a and d. You're just distributing a. Y'all see that? It's a times d c plus a times d. And then inner is the b and the c, the inside terms. You multiply those together. And then you multiply the very last terms, the b and the d. And so you end up with a setup such that the first AC, well, let me get my, no, it's gonna take too long. Try to get my colors right, but whatever. AC plus AD plus BC, your inner, plus BD, where A, B, C, and D just represent the first and second terms in each of the binomials. You almost did it. All right, and you've got that on page 188. All right, so let's look at it actually doing it. What does an example look like? All right, so for 3x plus 2 times x minus 5, what am I going to multiply together first? So Grace, what are my first terms? What are we doing with them? We're multiplying the first terms in each binomial. So the first one is 3x, and the second one is x. Right. So it will simplify to 3x squared. All right. Gabe, what's my what are my a FOIL? What are my outer terms? So I add again, what's my first term? 3x times -5. That's just a 5. We're just writing our outer terms, right? That would be our first and our last. So that's the 3x times -5. All right. Annie, what are my, so now I have my inner, FOI, inner terms. What are my inner terms? So the 2 on the inside. It's 2, yeah, 2 and x. In this case, just 2x. So what's my last terms? Olivia. So what's the last term in the first binomial? So 2 times -5. Yep. So these are my first terms in each binomial. And then we have the outer terms, the first in the first one, the last one in the second one. And then these are the inner, the 2 and the x. And it's just got to be extra. This is the last terms. Okay. And then we just combine. So what's 3x times x? 3x squared. All right. 3x times -5. -15x. You could also just write that as, excuse me, minus 15x. We'll simplify that in a second. All right, this one is just 2x. And then 2 times -5 is -10 or -10. All right, do we have any like terms we can combine? Yes. So 3x squared, we cannot. There's only one term that has an x squared, so we can't combine that. But we have -15x plus 2x. So what is that? -13x. So 3x minus 13x. So that got rid of these two. And then -10. And that's it. Wake up. Writing what I have as I go is definitely going to help keep you awake. Y'all do not want to miss this. You think the last test was difficult? All right. So when we multiply polynomials that have more than 2 terms, so we have trinomials with binomials or 2 trinomials multiplied times each other, it may help to use the vertical method. So all you're doing is you're using multiplication, but instead of multiplying the digits in 2 numbers, you're treating each term like a digit. So you're just multiplying them together. Let me show you what I'm talking about. All right, so write the factors in descending power of x like a normal multiplication problem. So I'm going to actually start, just like with a multiplication problem, you put the bigger number on the top as your multiplicand. So I'm going to have the 9a squared plus 4a minus 7. And then I'm going to line up, just again, like with multiplication, where the number in the ones place is right under the number in the ones place with your 2 factors. I'm going to do the same thing. So I have 6a minus 2. So I'm going to write the 6a under the 4a and the -2 under the -7. And you're multiplying. Yeah, we're going to do this both ways. You're multiplying. So just like when you multiply numbers, we're multiplying terms. Like you multiply digits in a multiplication problem. In this case, it'll be terms. All right, so -2 times -7. Positive 14. Yeah, that's a good one. Okay, plus 14. -2 times positive 4a. -8a. -2 times 9a squared. -18, 9a, excuse me, let me just write it down. -18a squared. All right. So again, just like in a multiplication problem, when we write our second partial product, or in this case, partial polynomial, you sort of annex in a 0, in this case under the 14. So now we have 6a times -7. And it's -42a. So I'm going to put that under my -8a. Because those are the two like terms. I can combine those when I simplify. Okay, 6a times 4a. 24. Positive 24a squared. All right, and 6a times 9a squared. 54a cubed. Yes, 54a cubed. So again, so I'm hoping that maybe the familiarity of this, this method might help you guys combine like terms. So you just, because all of these terms are exactly alike and we're adding or subtracting, then we can just combine them. Now, you just have to be careful because you're doing, like for the A term, you have -8a minus 42a. So you do not want to end up with that one being an a squared at the bottom. A is still a. We're just adding the coefficients, just like when we combine like terms like we have been since the beginning of the class. Okay, so this would be, just write this a little bit. So this is 14. And then what is my a term? -50a. Because they're like signs, they just happen to be negative. So -50a. -18a squared plus 24a squared. So we know this is going to be a squared. I would definitely write it out here if you need to. So we got to borrow. So that's 14 minus 8, which is 6, and then 1 minus 1. So 6, positive 6a squared. And because it's positive, I put the sign in front of it. And then there's nothing to combine that 54a cubed with. So it just comes right on down, just like the 14 did. Good? Makes sense. All right. Oh, it's a monster, but we're not going to have to multiply. We don't know what a is. Right now, we're just learning how to put them together. We're not solving any equations yet. Okay, so you can use the vertical method. Does everybody like this method? Or some of you? Does this make sense? It's kind of nice to just add them up, because if otherwise you have these as like a big long line and you have to find your like terms, remember to carry the sign in front of them with them, get them all combined together, which is what we're about to do here. So let's use the distributive method. This is what we learned in the first part, where just use the distributive property. In which case you distribute your first term to every term in the trinomial. And then you distribute the second term. Oh, you know what? Hold on. I'm gonna go to the bottom here, this way, to every term inside. Both work just as well. They'll give you the same answer. So this one is going to look like our second example, first or second example did. Except we, instead of having two binomials, we have a binomial times a trinomial. So 2x times 3x squared. This is going to get long. Let's see here. All right, so your first one is the 2x times 3x squared plus 2x times your second term inside the trinomial, which is x, plus 2x times -4. And now you do everything with the -5 as well, which I'm glad theirs fit. Mine's not going to fit. Ugh. Hold on. I'm going to move this. over, just a smidge. All right. All right, so this is you've got a -5 here, so just be really careful with this. So -5 times 3x squared. I'm just going to keep my -5, -5 times x. And the last one is -5 times -4. All right, now we simplify and then combine like terms. We'll get to that in a second. Okay, so what's 2x times 3x squared? 6x cubed. 2x times x, 2x squared. 2x times -4, -8x. -5 times 3x squared, -15x squared. -5 times x is just, right, -5x. -5 plus 20. All right. So what like terms do I have here? So I have a 2x, I have a positive 2x squared and a -15x squared. All right. And then we have an x term as well. Yep. Who's this? I love this color. All right, then we have a -8x minus 5x. Okay, so the 6x, and you'll notice again, just like when we did the vertical method, our highest term, highest exponent, and our lowest, our constant, don't have any like terms. We didn't have to add anything together. Remember when we did vertical, we just brought them on down. So it's kind of same sort of thing. All right, so those just come on down. So it's 6x cubed minus 13x squared. Thank you. Minus 13x plus 20. Yep, so -8, or excuse me, 2 minus 15, it stays negative, but it just goes a little closer to 0. So it's -13, and then -8 plus -5 is -13. And that's supposed to be a 20. And we're done. All right. All right. Everybody good so far? Okay, good. So we're not too intimidated by all of these letters. Of course, right now we've stuck to one letter. We just changed the exponent. It's really fun when you get like X, Y, Z all together. But it's still the same thing. Just match the variable and its exponent. Yeah. Probably only in Desmos, because they make like parabolas, and so they're like curves and circles and. All right, there are some very special products of binomials that we need to make sure we have memorized. They sort of are like rules. They will always work this way, and knowing these and having them available and knowing how to use them helps tremendously. All right, so conjugates are what we call two numbers that are written in the form a plus b and a minus b. So again, a has the same value, same variable, same value. We just don't know what that value is. B has the same value. Because of that, when they're written together, in ways that, when they're written together and then multiplied, you're always going to end up with a certain type of form. So if you look at two binomials and you realize that you've got like the same type of term, you've got like terms, and then you've got either addition, one is addition and the other one is subtraction, then you can simplify them in very specific ways. So it saves you a lot of extra work. So the product of conjugates means that if you have, what number do I'm gonna get a different color. If you have the binomial a plus b times the binomial a minus b, then you end up with a plus AB and a minus AB. So they cancel each other out. So you actually just end up with an answer. So you can just take your A and square it minus your B squared. We'll look at this, and I think we can get through this in practice. Wow. All right, we made through the whole thing. Huh? The AB cancels itself out. It's B times negative B, which gives you negative B squared. But it's plus AB minus AB. I'll show you. Right, because it turns into this. It turns into A squared plus AB minus AB, excuse me, minus B squared. And so this right here is your additive inverses. So those cancel each other out. So you end up with A squared minus B squared. Right. When we square, when you square one of the two, you end up with the same answer. A minus B and A plus B, because they're being squared. It ends up giving you all positive anyway. So this is, if you have A plus B and you have squared that binomial, that's the A plus B times A plus B, then it will always give you A squared plus 2AB plus B squared. And then if you ever have A minus B squared, you end up with A squared minus 2AB plus B squared. So it saves you the trouble of writing it all out of A squared minus AB plus B squared, and then having to combine those. It's just telling you they'll always end up that way, as long as the first terms in your binomials are the same and your second terms are the same. All right, so let's look at what this means in examples. I'm going to keep that up. All right, so this is going to solve it and show us where that comes from. Well, no, I'm not going to do that. I think y'all understand it. So 3y plus 5 times 3y minus 5 means that we're going to rewrite that in which of these three conjugates are we going to use? Product square of a sum or square of a difference? Product. Right, so this one is a product of conjugates. Example. So that means that our answer is just going to be A squared minus B squared. So what's our A term? 3y. So this is 3y. Make sure you keep it in parentheses because you're squaring both of them. 3y squared minus what? Just 5. Yeah. 5 squared. Oh. All right. So 3y squared is, right? 9y squared minus, always, you've got to square the whole thing. Remember, you think about the all of it together needs to be squared. So you have to square the 3 and you have to square the y. Okay. What about my second one? What is this? What is the conjugate? Okay, so that means our answer is going to be A squared. What's our A? Same thing, yeah. So 3y in parentheses squared plus 2 times 3y times 5, right? A is the 3y, 5 is the b, 2ab, plus 5 squared. All right, so this simplifies to 9y squared. 2 times 3 is 6, 6 times 5 is. Yeah, I'm just gonna, you can go ahead and combine all of your constants. 2 times 3 is 6, 6 times 5 is 30. That y just gets stuck in there. And then you have 25. Yep. All right, and last one, when we have the square, and I forgot to write it up there, sorry. When we have square of a difference, we end up with a squared. So 3y, come on, pen, don't fail me now. Squared, which we already know, minus 2 times the a term, which is the 3y, times 5. So we know what that's going to be here in a second, plus 5 squared. So the only thing that changes is that that middle term, that AB term, becomes negative instead of positive. So we just end up with 9y squared minus 30y plus 25. Any questions? All right, I'm just gonna fix this up so you can see it. 10 minutes. Yeah. There's one last question. Does everybody at least have the table? You have the table? If not, it's on page 189 in your book. Make sure you have that. I'm just going to move this up a little bit. All right, what kind of expression is the product of two polynomials? So we talk about this at the end. So when you look at all of these, what are these answers in example 5? What kind of expressions are these? Trinomials, polynomials. The first one's a binomial, but they're all polynomials. So the product, so they, maybe. Remember, product is the solution to a multiplication problem. So the solution to two multiplied polynomials is always a polynomial. So the set of polynomials is what kind of set? What do we call it when the answer is the same closed? So the set of polynomials is closed under multiplication. And we've seen this in all of our examples. So whenever your solution falls in the same set definition as the factors or the numbers that you're combining in some way, in this case, multiplication. So under multiplication, the set of polynomials is closed. So keep that in mind. When you are simplifying or multiplying polynomials together, your answer should always be a polynomial. The smallest you would have is a binomial. If you don't, then get something wrong. All right, that is it. We will spend time. I'm probably gonna pick some problems, have you guys work on the homework tomorrow as sort of a guided practice, just to see how well you understand this before we move on to the next section. All right, once you've got that, you guys are dismissed.